So welcome student. This is the another class of the structure of atom. So in this class we will read about what is quantum mechanics or what is wave mechanics, which is a very interesting and important part in our chemistry. So in the last video we have read different types of radiations, then line spectra of hydrogen atom. Yes or no? So before this concept, not a single scientist he could not explain the dual character of a matter. That dual character of a matter means the matter has both wave character as well as particle character. Clear? So Einstein was the first scientist who given the only concept of a dual character of a matter. Okay, but now we will read what is quantum or wave mechanics. So this quantum mechanics explain the dual character of a matter. Clear? So Einstein was the first scientist who given the concept. Davison and Jarmer was the first scientist who performed the experiment, and de Broglie was the first scientist who given the mathematical relation of a dual character of a matter. Clear? So that's why first we will read what is de Broglie wave equation. De Broglie wave equation. Okay, de Broglie wave equation. Now see, so according to Planck's quantum theory, E equals to h nu. So this is according to Planck's quantum theory. Similarly, E equals to mc square. This is according to Einstein. So E equals to mc square. This equation true when matter has a particle nature. Similarly, E equals to h nu, that is Planck's quantum theory. So this is true when the matter has a wave character or wave nature. So de Broglie what? Yes or no? What he had done? So he combined these two equations. So when he combined these two equations, he got the relation like this. You see, h nu equals to mc square. So nu equals to c by lambda equals to mc square. Clear? So one c will be cancelled. So we will get h by lambda equals to mc or lambda equals to h by mc. Clear? So what is lambda? Lambda is wavelength, h is Planck's constant, m is the mass of the particle, and c is the velocity of the light. But we know normally matter, yes or no, particle, not a single particle is present which can move in the speed of light. So that's why in place of c we can write h equals to lambda equals to h by mv, mass into velocity, or we can write lambda equals to h by p. What is p? P is momentum, or we can write lambda, h is constant, so lambda is reciprocal to momentum. Understood? So this is the mathematical equation of de Broglie wave equation. Got the idea? So E equals to h nu, Planck's quantum theory, E equals to mc square, Einstein equation. So what he had done? He had combined these two equations to get this relation that lambda equals to h by mv or lambda equals to h by p, or lambda is proportional to 1 by p. P is what? Momentum. So this de Broglie wave equation or the de Broglie concept, it is applicable only for microscopic particle, but it is not applicable for macroscopic particle. Understood? So it is applicable for microscopic particle but not applicable for a macroscopic particle. Okay, so suppose when we consider a macroscopic particle, take the mass. Yes or no? We know electron mass is 9.1 into 10 to the minus 31 kg. But if you take a ball, suppose whose mass is 10 gram. So if you put this value here, the lambda value will come 10 to the power something minus power. So that's why what? This is wavelength, but value is what? Coming negligible. So that's why de Broglie wave equation, it is only applicable for microscopic particle but not for macroscopic particle. Clear now? Okay, so it is only applicable to microscopic, not for macroscopic. Clear now? So this is called de Broglie wave equation. Understood? Then next part is Heisenberg uncertainty principle. What is Heisenberg? Heisenberg. Heisenberg uncertainty principle. Heisenberg uncertainty principle. So, what Heisenberg explained? Heisenberg explained when suppose the electrons are, you see, when the suppose electrons are revolving around the nucleus, yes or no, it is very difficult to calculate simultaneously the distance and the velocity of the electron simultaneously with 100% accuracy. Okay, so what Heisenberg said? He said it is impossible to calculate with 100% accurate or 100% accuracy simultaneously. The position and momentum of an electron cannot be calculated. Clear? So, what is the mathematical relation? So, he given the mathematical relation del x into delta p greater than equals to h by 4 pi. What is del x? Uncertainty in position. What is del p? Uncertainty in momentum. Okay, h is the Planck's constant and 4 and pi, these are the what? Number and constant. Clear now? So, what is del x? Position in distance. Uncertainty in position. What is delta p? Uncertainty in momentum. Sir, why uncertainty name is given? Because if del x is calculated with 100% certainty, means accurately, then 100% delta p value will be uncertain. Okay, so you see, so if you expand this, del x into p is momentum, formula mv, so m into delta v equals to h by 4 pi, or we can write del x equals to h by 4 pi m into del v, or delta v equals to, we can write h by 4 pi m into del x. Clear? So these are the formula. So remember, when we will solve the numerical, we will write equal, and when we will write only theoretical aspect, we will write greater than equals to h by 4 pi. Now see why it is given uncertainty. So you see, this is a microscopic particle, very small. It is not what visible to our eye. If it is macroscopic, it is visible, we can see. So when it is a microscopic particle, it is not what seen also in our naked eye. Okay, so Heisenberg said, suppose if you fit here one microscope, yes or no, then incidence some light radiation to see the electron or to see the or to locate the electron. But according to Planck's photoelectric effect, we know when a beam of light falls on this, ejection of electron takes place. So that's a very difficult to locate the electron. But what Heisenberg said, suppose when the electron is revolving around this, suppose first we have to calculate the distance. So when you are calculating distance between these two particles, yes or no, 100% the electron should be at rest. Otherwise, how will calculate the distance? Yes or no? Will you run behind the electron? Okay, you stop. So that's why you see, so when we are calculating the distance, the electron should be at rest. So you see, if we use this formula, so we are calculating del x. So del x equals to h by 4 pi m into delta v. Here we have taken body should be at rest. Velocity is 0. So something by 0 we cannot define. So that's why if we are calculating del x value with 100% certainty, then it is very difficult to calculate what delta v. Why? Here we have taken delta v 0. So it is not possible. Similarly, when you are calculating delta v, when you are calculating the velocity, yes or no, then we cannot calculate the distance with 100% accuracy. So that's why Heisenberg said it is very difficult to calculate the exact position and exact momentum or velocity with 100% certainty. We cannot calculate. Okay, so Heisenberg only explained this theory is applicable for microscopic particle, not for macroscopic particle. Got the idea? And Heisenberg said when the electrons are revolving around the nucleus, the electrons are revolving in a definite trajectory path, but he could not explain what is this path. And he explained electron is not present inside the nucleus. He proved this. I will explain now. So he explained electron is not present inside the nucleus. So if the electron is not present inside the nucleus, where electron is present? 100%, except nucleus. In other region, in extranuclear region, electrons are present. So how can we prove, you see? So we can prove by contradiction method. Suppose you see we are calculating velocity, right? So delta V equals to h by 4 pi m into del x. Now contradiction method. Let electron is present inside the nucleus. Let electron is present inside the nucleus. So if you put all the values, h value 6.625 into 10 to the power minus 34 joule second by m, mass of the electron 9.1 into 10 to the power minus 31 into 4 into pi 22 by 7 into where the electron is present? Electron is present inside the nucleus. Okay, so we'll put the radius of the nucleus. The radius of the nucleus is 10 to the power minus 15 centimeters. So you see, if you substitute all these values, yes or no, multiplication and division, then we'll get the value 5.77 into 10 to the power 10 meter per second. 5.77 into 10 to the power 10 meter per second. So which value, yes or no, is greater than the speed of light? That means we know nobody can move with the speed of light. So when the electron is present inside the nucleus, the velocity of the electron will come greater than the speed of light, which is not possible. So we have taken a contradiction method. That means electron is not present inside the nucleus. Electron is present except nucleus. Any outside region, electron is present. Got the idea? So both de Broglie and Heisenberg, they could not explain the three-dimensional model of the atom because this is wave mechanics, yes or no, or quantum mechanics, where dual character of matter we are reading. So they explained the properties, but they could not explain where the electrons are present around the nucleus. Yes or no? Bohr theory only explained electrons are present around the nucleus in a circular path. But Bohr could not explain the three-dimensional path. Yes or no? So after this, here, which concept? Three-dimensional concept is coming, and in our CBSE as well as in NEET format, yes or no? Direct Bohr theory is not given. Bohr theory direct will read in principal quantum number, because principal quantum number is itself, it is Bohr's atomic model. Clear now? So that's why first is de Broglie wave equation and second one is Heisenberg uncertainty principle. Clear now? Yes or no? So after Heisenberg uncertainty principle, the next dual character of matter is Schrödinger wave equation. Okay, so actually Schrödinger explained everything. Understood? So Schrödinger wave equation, so the dual character of matter and the three-dimensional concept of atom was properly explained by Schrödinger. So Schrödinger, he explained the three-dimensional model of the atom. Clear now? So when Schrödinger explained On the basis of the dual nature of matter and Heisenberg uncertainty principle, Schrödinger developed a new branch of science called quantum mechanics or wave mechanics. The mathematical equation is known as Schrödinger wave equation. Clear now? So, he explained the three-dimensional model of the atom. So, in our CBSE as well as in our NEET format, always you will remember only the equation part. Okay. So, from this concept, no numerical questions are coming. So, here you will remember, so he explained that psi equals to a sine 2 pi x divided by lambda. That means when he explained in three-dimensional concept means how many axes? 3 axes. Yes or no? So consider when the radiation is moving in 3 dimension in x axis first, he explained that psi equals to a sine 2 pi x by lambda. What is psi? Psi is called wave function, a is amplitude, 2 pi, lambda is wavelength, and x is your displacement along x direction. Okay, so like this, how many equations will come? Like this, 3 equations. One in x axis, another is in y axis, and another is in z axis. So total 3 equations will come. Clear? Now, if we will take the double derivative, first we will take single derivative, means this is psi. Then one d psi, one mathematical equation will come. Then we will take its double derivative, d square psi. Yes or no? So if you will take a double derivative of 3 equations, add the 3 equations, then you will get one equation. Okay, again. So like this total, how many equations will come? 3 equations will come. So take the double derivative. Yes or no? And you will add the 3 equations, then we will get d square psi by dx square plus d square psi by dy square plus d square psi by dz square plus 8 pi square m by h square into e minus v into psi equals to 0. So this is a very important equation. So this equation is called Schrödinger wave equation in 3 dimensions. Okay. So E is the total energy, V is the potential energy. Okay. And these are all are what? 8 pi m. These are all are what? Constant. Clear now? So you will remember this equation. This is called the Schrödinger wave equation in 3 dimensions. So in place of this, because this is a very big equation, in place of this, we can write like this. Del square psi plus 8 pi square m by h square into e minus v into psi equals to 0. So this del square, this is known as a Laplacian operator. This is called a Laplacian. This is called a Laplacian operator. Clear now? Okay, so this equation you will remember. Now, next is Schrödinger wave equation can also be written in this format. You will remember like this. H cap, you see. H cap psi equals to E psi. So, the Schrödinger wave equation can also be expressed in another format, that is H cap psi equals to E psi. Here this H cap is called a Hamiltonian operator. Hamiltonian operator. Got the idea? So you will remember Schrödinger wave equation in one direction. Okay, Schrödinger wave equation in 3 direction, double derivative equation. Okay, psi has no physical significance, but psi square has physical significance. Okay, so psi is called your wave function or amplitude function, but psi has no physical significance, but psi square has physical significance. What is psi square? Psi square is called the probability of finding of electron. The probability of finding of electron. Understood? So it is the 3-dimensional space where the probability of finding of electron is maximum. 3-dimensional path. This is called orbital. So Schrödinger explained the 3-dimensional concept of the atom. Clear now? Yes or no? So from this concept, what is coming? that is quantum number concept is coming. So that's why, understood? So this is the Schrödinger wave equation or quantum mechanics, one direction, three direction, double derivative equation, this equation, okay, Hamiltonian operator and a Laplacian operator. Clear now? No numerical, only fundamental question part you will remember. Clear? So from this concept is coming, what? Your quantum number. So concept is coming quantum number. Okay. So earlier actually quantum number, these are the actually solutions of Schrödinger wave equations. Okay, but now we are reading little different definitions. So what is quantum number? Actually quantum number, these are the certain numbers, so by which we can explain the address of an electron. Understood? Suppose you see, if you go to any foreign country, yes or no? So when any suppose Indian will ask, you belongs to which country? Then first you will tell, I am from India. Then next, if he or she is an Indian, then automatically in Hindi, he or she will ask, in which country, कौन सा country में है, कौन सा state में है? Yes or no? Then you will tell, I am from Odisha. Then if he or she is an what? From belongs to Odisha, then directly in Odia he will ask, yes or no? That you are from which town? Clear? Then you will tell, I am from suppose Bhubaneswar. Then if he or she belongs to Bhubaneswar, then definitely he will ask in which locality or in which area. Yes or no? Then you will tell, sir, this is in CRPF square. So like this you see, so what is your position? So your position in the country is, you are from country India, state Odisha, town or city Bhubaneswar, and position is what? Your CRPF square. So that's why you see these are the what your address of year. Similarly, when the electrons are present around the nucleus, so what are the different factors or what are the different terms which can explain, yes or no, different informations of electron, yes or no? So this is called quantum numbers. So quantum numbers, these are the numbers which can explain the position, energy, orientation, yes or no, everything around everything of an electron. So that's why quantum number, these are of four types. That one is called your principal quantum number. Principal quantum number. Second is called azimuthal quantum number. Okay. Third is called magnetic quantum number. Magnetic quantum number. And fourth one is called spin quantum number. Principal quantum number symbol is N, azimuthal is L, magnetic M, and spin quantum number is S. So principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. But you will remember these three quantum numbers, these are derived from Schrödinger wave equation, but spin quantum number is not derived from Schrödinger wave equation. Okay. Fundamental part, remember. Clear? So earlier I said that direct Bohr theory, what it is not in our syllabus, but Bohr theory is what? Principal quantum number is everything is about Bohr's atomic model. Clear? So if you know about principal quantum number, then which type of information will get about electron? Similarly azimuthal, similarly magnetic, and last is spin quantum number. Clear? So first is principal quantum number explained what? So first is principal quantum number symbol is M. Understood? So principal quantum number, first it explains the number of cells present in an atom. So first it explains number of cells. Quickly you will remember principal quantum number explain about cell, azimuthal quantum number explain about subcell, magnetic quantum number explain about orbital, spin quantum number explain about spinning of electron. Cell, subcell, orbital, spinning. India, Odisha, Bhubaneswar, CRPF square, like this. So yes or no? So quantum number explain everything about electron. So principal quantum number first explain the number of cells. So representation is n. So when you will remember, when n equals to 1, that is k cell, n equals to 2, l cell, n equals to 3, m cell, n equals to 4, like this, k l m n o p. So principal quantum number first explain the number of cells. Second, principal quantum number explain the number of electrons in a cell. Number of electrons in a cell. Number of electrons in a cell formula is 2n square. Okay. So if you put n equals to 1, then that means k cell contain how many electrons? 2. If you put n equals to 2, l cell, that is 2 into 2 square, that is 8. If you put n equals to 3, then m cell, that is 2 into 3 square, that is 18. N equals to 4, k l m n cell, so 4 square, 16 into 2, 32, like this. So the second information, principal quantum number, what it explain? It explain about number of electrons in a subcell. Clear? Then third information, what he explained, that third information is the energy of electron in a cell. Okay, energy of electron in a cell. So energy of electron in a cell, that is En equals to minus 1312 divided by n square, that is kilojoule unit, or minus 2.18 into 10 to the power minus 18 by n square, that is joule per atom, or minus 13.6 by n square, that is electron volt per atom. So in different unit you will remember. Okay. So first is in kilojoule unit, and next is what? In joule per atom unit, or 13.6, that is electron volt unit. So what is n? N is the principal quantum number. Clear? So principal quantum number also explained the energy of electron in a cell. That is actually Bohr's theory also. Okay. Then fourth, what is the fourth information given by principal quantum number? The fourth information is radius of an cell. So radius of an nth cell, okay, that is Rn equals to how much? That is Rn equals to 52.9 into n square. 52.9 into n square in picometer unit. Okay, 52.9 into n square. This is radius of nth orbit. Clear? Similarly, principal quantum number also explained the velocity of the electron. Okay, so velocity of the electron in each cell, that is Vn equals to 2.18 into 10 to the power 8, yes or no, into, that is Z by n meter per second. Clear? So this is the velocity, this is radius, this is energy. But all are, you will remember, all are for hydrogen atom. But from the very beginning we are reading, this theory is also applicable for hydrogen like atom. So when hydrogen like atom will come, in energy you will multiply, for hydrogen like atom you will multiply Z square. What is Z? Z is the atomic number. Similarly, in radius for hydrogen like atom, then if you will multiply, that is n square by Z. What is Z? Z is the atomic number. Clear? Okay, so here also Z. So this is energy explained, radius explained, then velocity also explained. Understood? So in the last class we have read that is line spectra. So line spectra is also explained by which principal quantum number. Understood? So these are the different informations. Next information is principal quantum number also explained the angular momentum of an electron. Okay, angular momentum. What formula? MVR equals to NH by 2 pi. MVR equals to NH by 2 pi, or we can write MVR equals to N into H cot, because H by 2 pi, this is a constant value. So that's why in place of H by 2 pi, we can write H cot. So angular momentum equals to like this. Clear now? But you will see one shortcut is there. How can we remember the angular momentum? Because all four quantum number explained the angular momentum. Principal quantum number explained the angular momentum of an electron in a cell, azimuthal in a subcell, magnetic in a orbital, and spin quantum number using spin quantum number part. So how can we remember? So these are the actually information explained by principal quantum number. These are actually Bohr's atomic model: cell, number of electron, energy, radius, velocity, angular momentum, and line spectra. Clear? So how can we remember quickly the angular momentum in terms of all four quantum number? You will see we are reading four quantum number. First and third format is the same. Second and fourth format is the same. This is N, this is L, this is M, and this is S. So if we use N, angular momentum is what? NH by 2 pi. And what I said, first and third format is same. So it's MH by 2 pi, angular momentum. Similarly, second, fourth format is same. Second angular momentum is L into L plus 1 root over H by 2 pi. This is the second. Okay. And in terms of S into S plus 1 root over H by 2 pi. So remember this. These are the how we can quickly remember that angular momentum of an electron, yes or no, explained by four quantum numbers: principal, azimuthal, magnetic, and what? Spin. Clear now? Okay. Then next come to azimuthal quantum number. So after principal quantum number, next is azimuthal quantum number. So azimuthal quantum number symbol is L. So first what I said, it gives idea about subcell. L equals to formula 0 to n minus 1. Okay, that means you see, so in K cell, what is the n value? For K cell, n equals to 1. So that means in K cell, how many subcell is present? So 1 minus 1, that is 0. So here L equals to 0. That means in K cell, only one subcell is present whose L value is 0, which is known as S subcell. Got the idea? Similarly, L cell, n equals to 2. What is L value? 0 to n minus 1 means L equals to 0, L equals to 1. So 0 means S subcell, 1 means P subcell. Clear? Similarly, M cell. So M cell means n equals to 3, L0, 1, 2, S, P, D. 3 subcells. N cell. So N cell, n equals to 4, L equals to 0, 1, 2, 3. S, P, D, F. Like this. Clear? After this S, P, D, F, G subcell will come. Understood? Now, you will remember like this. This is the first cell. So its subcell is 1S. Second, 2S, 2P. Third, 3S, 3P, 3D. Fourth, 4s, 4p, 4d, 4m. So that's why you will see first cell, one subcell. Second cell, two subcell. Third cell, three subcell. Fourth cell, fourth subcell. So that's why you will remember questions are coming like this. In nth cell, how many number of subcells are present? N number of subcells are present. So got the idea? So for S subcell, L value always 0. For P subcell, L value always 1. For D subcell, L value always 2. Yes or no? Then for F subcell, L value always 3. Like this you will remember. Clear? So this is the first information given by what? Azimuthal quantum number. How many number of subcells are present in each cell? Then next I said angular momentum. Angular momentum already I said angular momentum equals to small l into l plus 1 root over h by 2 pi or l into l plus 1 root over h cot. What is L? L is the azimuthal quantum number. So question, what is the angular momentum for S subcell? So S subcell means L value 0. So L value 0 means always angular momentum of S subcell is 0. What is the angular momentum of P subcell? So L is 1. So put 1, 1 plus 1, 2. So root 2 h cot. Okay. In D subcell, value is what? 2. So 2 plus 1. 3 into 2, root 6 h cot. Like this. So all fundamental questions are coming from what? Deep level. So you have to remember everything. Clear now? So this quantum number also given idea about what? Number of subcell in a cell, then azimuthal quantum number. Also explained angular momentum. Then like principal quantum number we know K cell, after K cell L, then M, then N, like this will come. Because these cells are arranged according to energy. Similarly, according to subcell format, 1s, 2s, 3s, so which subcell will come in which order? Okay, so that is called N plus L rule. So this quantum number means azimuthal quantum number also given the idea about relative what energies. Relative energies of various subcell, of various relative energies of various subcell. So various subcell can be explained by N plus L rule. So you will remember like this: 1s, 2s, 2p, 3s, 3p, 3d, 4s, like this. Okay, so N value, L value, N plus L value. Clear? Yes or no? N value, L value, N plus L value. So N 1, L 0, 1, 2, 0, 2, 2, 1, 3, 3, 0, 3, 3, 1, 3, 4, then 3, 2, 5, then 4, 0, 4, 0, 4. Like this, what it will come. So the relative energy you will remember, whose N plus L value is lowest, its energy is less. Clear? Whose N? So that's why first order will come 1s less than 2s less than. So if N plus L value will be equal, then you will remember. Suppose 2p its N value is less. So if N plus L value are equal, then the subcell whose N value is less, its energy is less. So that's why 1s less than 2s. After 2s, 2p less than 3s less than 3p. Okay, then 3d is 5, 4s is 4. So which one will come? 4s. So after 3p, 4s, then 3d. Like this it will continue. Clear? So this is your relative energies. But in another shortcut format, how can we remember? You see, another shortcut format, you will write like this. You will write like this. You see, 1s, 2s, 2p, 3s, 3p, yes or no, 3d, 4s, 4p, 4d, 4f, like this. So you draw the line like this. Okay, 5s, 5p, 5d, 5f. So then you can remember 1s, then 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, like this it will continue. And you know this is called your Aufbau principle. Aufbau principle. Yes or no? So the filling of subcells or the filling of electron takes place in various subcells, increasing order of energies. So this concept also explained by which quantum number? This concept also explained by your azimuthal quantum number. Okay. So this quantum number explain the shape of various subcells present within the main energy cell, and this quantum number also explain the fine spectrum. Only remember this line. This quantum number is also known as subsidiary quantum number, yes or no, or secondary quantum number also. Clear?